Now let's talk about two kinds of material that we use in our plumbing systems, fixtures and pipes. First, fixtures. A fixture is something that is fixed in place. That means it doesn't move. So you could have a light fixture, for example. If a fixture has water flowing through it, it brings in water and distributes it. That's a plumbing fixture. So a plumbing fixture could be a faucet or a sink or a toilet or any fixed object that uses water. One fixed object, one fixture, is a sink, and in a bathroom we call a bathroom sink a lavatory. And you will hear builders and architects sometimes talk about the lav. Where are you putting the lav? Lav is short for lavatory. And this comes from a Latin word, lavare, meaning to wash. And you see variations on that Latin word show up in the Romance languages, Spanish, French, Italian. And here it is in English, lavatory, a bathroom sink. It can also be the room that contains the bathroom sink. Another word that we use, we say water closet to refer to the toilet. Don't ask me why, but we do. So the water closet, the WC, is a toilet. And in houses at a residential scale, as we discussed earlier, a water closet operates with a siphon, with a partial vacuum that sucks the water and waste out. Now let's talk about pipe. Well, there are several kinds of material we can use for pipe. What's important is that it be smooth and have low friction so that the fluid flows through, and that it resist corrosion. So we don't want iron pipe, but we might want steel pipe. There are certain kinds of pipe materials that are permitted by code. You'll notice that lead pipe is no longer legal. Back in the 19th century, early 20th century, you'd hear people talk about lead pipe. And in fact, the Romans used lead pipe, and they suffered lead poisoning as a result. So we don't use that anymore. We do use copper, steel, and various kinds of plastic. Now, PVC, which stands for polyvinyl chloride, is a very common plastic material used in plumbing, and it has a problem. The problem is that when it's heated, it gives off dioxin, which is toxic. It's a poison, and it's one of a group known as a persistent organic pollutant. Organic means hydrocarbon. So it's a toxin, and if you have a fire, for example, dioxin is given off, and it is toxic to living things, including people. There's also a problem when PVC pipe is manufactured, because PVC has to be heated up in order to reach a liquid state so it can be formed, molded. If you look at cancer cluster maps from the Centers for Disease Control, look at where PVC plants are in the U.S., and then compare that with where certain kinds of cancer clusters are, and you will see that there's a correspondence. So these things are problematic. At this point in the U.S., PVC is completely legal. In a number of European countries, it's now illegal. So stay tuned. Let's talk about pipe size now. When you see somebody write NPS, nominal pipe size, that means nominal pipe size means the name of the pipe size. So if you say 1.5 inch pipe, that's its name, that's not its size. In the 19th century, 1.5-inch pipe was 1.5-inch inside diameter, and it was made out of steel, and that was the size. And then it was bigger on the outside, of course, and we had threaded fittings that screwed over these pipes. Well, then the steel making process was refined. Steel making got better, and manufacturers were able to make steel that was stronger. That meant they didn't need to use so much steel in making their pipes. They could make the pipes thinner and still have them be strong. And that was a benefit because we buy steel by the pound, and the more steel we put in our pipe, the heavier it is. Obviously, the more it costs. The more it costs to buy and the more it costs to manufacture. So making thinner pipe was an advantage. However, by the time this developed, we already had a large supply of threaded pipe fittings that would fit over the outside of these pipes. We had unions and elbows and T's and reducers and all those kinds of fittings. So it would not be economical to change the outside size of the pipe because we had all these fittings in stock. What manufacturers did then was they made the wall thickness thinner by making the inside diameter get bigger. So they left the outside diameter the same. They made the inside diameter bigger, and therefore the wall thickness was a smaller thickness. So there's that. Now, the systems of pipe manufacturing, and there were two major systems. The systems of pipe manufacturing created these schedules, and there were a whole bunch of them originally. Schedule so-and-so says the pipe is this size outside, this much wall thickness, and so on and so forth. Nowadays, we have come down to using just 3 basic schedules. And let me just say that originally, when all this stuff developed, those 2 manufacturing standardization groups intended to come together and use the same sizes. But by the time they got all this rolling, they both systems had so much pipe and so much fitting out in people's inventory, nobody could afford to change over and switch to one system. So we have 2 systems. Ordinary pipe, standard pipe, you go to the hardware store, you say, please give me some pipe. That is called standard pipe. It's also called Schedule 40. Standard pipe is Schedule 40, and we're going to go look at a pipe schedule in the Far West Steel catalog in just a second. You can get pipe that is heavier. It's called extra strong, also known as extra heavy, also known as Schedule 80. And when you look at the picture down here, you will see that the outside diameter of the standard pipe and the extra strong pipe remain the same outside diameter so that we can use the same pipe fittings on them. It's the wall thickness and therefore the inside diameter that changes as the pipe gets heavier. Then the heaviest kind is called double extra strong, also known as double extra heavy. And this is where the 2 systems of manufacturing standards parted ways. This is where double extra strong, or double extra heavy, is a different thickness than Schedule 160. But still, the outside diameter stays the same. So let's go look at a table. This is a table of pipe sizes from Far West Steel. You may have seen Far West Steel around Lane County. They're a big steel supplier here, and one of the things they sell is pipe. So here is their table from their catalog. And here are some thinner schedules of pipe, but we don't use those much. Here is Schedule 40, also known as standard. Here is Schedule 80, also known as extra strong or extra heavy. And over here on the far right, here is Schedule 160, which is slightly different from double extra strong or double extra heavy. So let's compare some sizes. Let's say we're looking up 1.5" pipe. So here on the left is a column for pipe sizes, and I have highlighted 1.5" pipe. Let's look at the outside diameter. All right, 1.5" pipe is 1.9 outside. Now let's go look at the wall thickness. This column here is wall thickness for Schedule 40. This column here is wall thickness for standard, and you'll notice the wall thickness is the same in those two systems. So, backing up, if we have a pipe that is 1.9 outside diameter, and it's 0.145 wall on this side and 0.145 wall on this side, what is that? That's 0.29 altogether. So 1.9 minus 0.29 is not 1.5". So the inside diameter is not 1.5", and the outside diameter is not 1.5". Nothing is. That's its name. That's its nominal size. Now let's look at Schedule 80, or extra strong. Its wall thickness is 0.2. Again, each side of the pipe is 0.2. 0.2 here, 0.2 here. So that's a total of 0.4. Oh, looky there. For extra strong, 1.9 minus 0.4 gives you 1.5, if you're following along with your calculator. So it happens, almost through sheer coincidence, that extra strong pipe is 1.5" inside diameter. That's not true of all the other sizes. And then here's Schedule 160. It's still 1.9 outside diameter, but it's got a thicker wall thickness, 0.281. And if you go to double extra strong or double extra heavy, it's got a wall thickness of 0.4 on each side. Now, I would like to show you where you can find this catalog with this table. So I'm going to get out of here and go to our Google Drive. Here's our LCC drafting courses. This is where we get our architectural plans. And so here are all these drafting courses, and you're welcome to help yourself to materials from any of these. There is a folder right here near the top called Reference Materials. And in the reference materials are some things, including, if you scroll down, here is the Far West Steel catalog. So if you want to open that Far West Steel catalog, you can, and you can go to the end where their pipe is. It's way the heck. See, here's the catalog. Way at the end is going to be their pipe. Whatever page that was on. Kind of hard to find with this thing. There it is. Page 80 of the